Hello viewers, welcome to the iAutomation YouTube channel. This video is regarding upcoming PLC code challenge on October 28th. So we are going to discuss like what are the types of problems could be possible in a PLC code challenge, and I'm going to solve one PLC project that is on tank control, water level control. So that how you can use the PLC basic commands explained earlier in videos, so that to solve the practical application. Okay. So let us go to the like what are the types of problems could be possible PLC challenges. Say for example water level control simulation. Uh, in this there is a sump and then there is a overhead tank, and overhead tank has got two sensors and sump has got one sensor to check the whether sump is has got enough water. Okay, and there is a water pump. Sorry, that is a motor pump is there here, and to switch on the enter control there is a on switch is there. Okay, so this could be around four inputs, one sump sensor and tank level, low level and high level, and then on switch. So totally four inputs and one output. This is a problem statement. Okay, this is one of the problem could be possible. Basically like the problem statement will be like one problem statement should use like more commands, like that the problem will be challenge will be. I'll give you a problem where more commands you should use. For example, timer, counter, rising edge, falling edge, then greater than or less than, latching function, or signal or set and reset function. Okay, so like that you should explore more commands in a single problem statement. That is what the problem will be like that. Okay, this is tank control, water level control simulation, water controller. That is one could be, and conveyor control. So here there is an empty bottle loaded on the start of the conveyor belt, and to run the conveyor belt there is a motor is here. These are the idle rollers. So this is not the motor. There is one motor is there. If motor is on, conveyor belt is on. Conveyor belt is used to transfer the bottle from start point to the end point. Okay, empty bottle is loaded here. To sense that there is a sensor here or the switch here, it comes to the proper position where it will stop. Conveyor belt is going to stop, and then filling process will be completed, and then capping process will be completed, and then the filled bottle will go to the end of the conveyor belt, and that completes one cycle. Okay, so this will be like problem statement, and this is having around three inputs and three inputs and two outputs. Sorry, three inputs and three outputs as a problem statement. Okay, and problem statement will be given. So as per the problem statement, you should write the solution and then send it to us. Three inputs and three output. And there could be a lift control simulation. Lift control, the four floor will be there, three floor will be there. So here four inputs are there, or to request ground floor, first floor, second floor. So here four inputs are there, and then respective LEDs, that means four inputs and four outputs are there. So this is a problem statement. This could be possible. Four inputs and four outputs. And staircase control is very simple. This not be possible in the PLC code challenge. This is traffic control is possible using greater than or less than comparators. Here two lanes are there, lane 1 and lane 2, and since Delta PLC has got only 6 digital outputs, so we have used only the 6 LEDs. Okay, here only one input. Okay, one input is maybe start button. Okay, and then 6 outputs are there. So traffic control simulation, you know this traffic control going to work. Means lane 1 if it is green, then lane 2 cannot be green, it should be red. Okay, and to change from red to green there is a yellow light is there, so in between, uh, so that is the required simulation. This also could be possible traffic light simulation. Okay, so these are the possible types of problems could be appearing in the challenge, PLC challenge. Okay, so I'm going to solve the water level control problem, so that I'm going to demonstrate how to use the explained PLC commands to solve the practical application. Okay, so this I'll read out the problem here. Water level control using PLC comprise of sump, that is storage tank, and overhead tank, and a water pump, and three sensors altogether. That is, one sensor is fitted to the sump to sense the water low level, and the other two are fitted to the overhead tank, that is high level and low level sensor. The logic is to switch on the pump only there is a water in the sump, and when overhead tank is low. This is very important. The logic is to switch on the pump only there is a water in the sump, and when water overhead tank is low. Okay, stop the pump once overhead tank is filled. So this has to be fulfilled. So one can easily understand this problem because it's a daily, it's a very familiar problem statement. Every house has got a overhead tank and the sump and the pump motor and the pump, right? It's a usual general problem. That means there is a sump sensor, right? So when there is enough water in the sump, then only motor pump should be on. Means pump should be on. Otherwise, there will be a cavitation problem, and there is a problem to the motor also, right? Means pump and motor there is no load, but it's pumping, and then cavitation problem means there is a damage to the pump. So we should not run the pump if there is no water in the sump. Okay, and uh, here when water level is full, then pump should be off, right? When water level is completely empty or low level than the low level sensor, then pump should be on automatically. So this automatic automation is involved. Okay, so no need to watch whether it is full or not. Okay, so manual means uh, manual labor is not involved, or the person is need not to be involved in this because it's completely automation. uh, so now the problem statement, see how I'm explaining like how you should approach the problem, okay, to solve it. So first of all you should count the number of inputs and output. Okay, so here input is there are four inputs are there: on switch, and then some sensor low, that is some sensor is there, and tank has got two sensor, low level and high level. So total four inputs are there, and one output is there, that is motor pump. That means if you switch on the motor, then pump is going to on, right? It's a problem statement, and this is the number of input. This is the very first step. uh, Listing the inputs, on four outputs are there, but since we are demonstrating the delta PLC here, so address format is different here. Say for example x0, and some sensor is x1, tank low level sensor is x2, and tank high level sensor is x3, and motor pump output is y0. This is with reference to delta PLC. Okay, now the question is how to solve this problem. Okay, so I'll tell you one approach. This approach can be used in all PLC projects. So for example, how many number of output is there? Only one. Now the question is when to switch on the motor, when to switch off the motor. Like this way we can think. Okay, so you have to list the conditions when motor to be on. You have to list the conditions when motor to be off. So that is the best way to approach the problem. What I'll do is to understand that, I'll take a word file. Say for example there is a motor. When motor to be on, so let us have a okay. Say for example motor pump that is on status. Let us take, say for example, motor on and motor off. That is Y0. We are talking about Y0 output. Okay, when motor to be on and when motor to be off. This is the condition. Now we'll go back to the problem here. Okay, we'll go back to the problem. So now you just think yourself and then write down on the paper what are the condition motor to be on. Motor to be on. Say for example, when on button is on, if water is empty in the tank, if on button is on, motor should be on, right? That's the condition. So I'll here that is on switch. If I operate on switch, motor to be on. And sorry, and what are the condition? If enough water in the sump, then motor should be on, right? If enough water in the sump, then motor should be on. Otherwise, motor should be off. If there is no water in the sump, then motor should not be on. So let us take that way. That means if sump sensor is off, if some sensor is off, then motor to be off. That's the condition. And when motor to be on again, when low level sensor is off, that means there is no water. So when low level sensor is off, so let us like that, on switch is on, and then motor to be on. Then if low tank, that is tank low level sensor is off, that means tank is empty. Then motor to be on. Okay, like that. When motor to be off, when tank high level sensor is when tank high level sensor is on, motor to be off. Correct. So before this, if you want to understand how sensor is going to work, see, sensor can be uh, can be NO or NC type, normally open type or normally closed type. But our consideration is sensor is normally open type. Our consideration is sensor normal open type. Okay, that means I will going to elaborate it. If water level, or if water is present, if water level is equal or greater than sensor position or sensor level. If water level is equal or greater than sensor level, what is the sensor condition? Sensor is on means it will generate an output of 24 volts, so that it will go to the PLC, and PLC understand that there is an input on. Okay. if water level is lower than sensor level, it means it assumes that there is no water near to that. So sensor is off, that means it is 0 volts. No, so this is the condition for normally open type. Okay, this is a normally open type we have considered. That means if there is no water near to that, sensor is off state. If water is present near to that, then sensor is on. So it is going to generate 24 volts to the PLC. Okay, so this is a matrix. This matrix you have to refer. Based on this matrix, I am going to write the program. Here we can use the set and reset function so that it becomes very simple and the number of lines will be less. Okay, so let us construct this program, WPL software. So open it and tank control. The PLC type should be SS2. Okay, and now I'll take X0, that is start. Sorry, here X0 we have taken on switch. Okay, on switch. X0 is on switch. And next, but here X0 we are assuming it as a push button. Remember that we are assuming it as a push button. Just briefly operated and then released. So I'll zoom it. Okay, this is X0. Please enable the comments also so that text will be available here. X0 I've taken as a, see here, this condition. I'm writing the program for motor on. Motor on means that is Y0, and I'll use set reset function, that is set, and Y0 I have to set it. So what are the other condition to motor to be on? That means tank low level sensor is off, means sensor, if see here, this condition, if sensor is off means there is no water. If tank is empty, then motor to be on. So how do I know tank is empty? So I'll use falling edge detection for this. Falling edge detection of, what is the sensor, tank low means X2. So here tank low. Okay, what is the use of falling edge? See, at the time of filling, say for example at the time of filling, sensor is on initially. Okay, so tank is full, so high level sensor is on. When tank is really empty, so what happens at that time, low level sensor is going to off. Okay, at that time it should generate a pulse to switch on the motor again. When low level sensor is on and then off, that means one filling is completed and then draining is completed, so that when tank is really empty, then again tank should be on again. That's the logic. Vertical line. Okay, I'll explain with animation also. So just I'm writing the program. So now I've written a program to when motor to be on, when motor to be set. For example, Y0 is, what is Y0? Y0 is, so I'll put it in a device comment. So Y0 is motor, pump, so motor pump, right? So motor pump, and now I'll write down the instructions when motor to be off. Okay, see here, when motor to be off. If some sensor is low, then motor to be off. And when high level sensor of tank is on, high level tank is address, that is X3. See, on means normally open, off means normally close. So X3 I'm going to use on because it is tank high. Tank high. So if it is on, then I'm going to use a reset function. What I should reset? That is Y0. Okay, and this, look at this condition. So some sensor is off, then motor to be off. So off means normally. See, if you observe here, on means normally open I'm using. Off, okay. This is a little tricky. Okay, we have to use normally open here only, but here falling edge I'm using. But here some sensor is off means normally close I should use. Okay, that means normally close of X1, that is sump sensor, and I'm going to use vertical line for this. It's a very simple program, 2 lines program. When motor to be on, when motor to be off. Okay, so before explaining this program, so what I'll do, I'll take the animation. So for that, there is advanced version of PLC program, that is ISP is there, so that I can use some HMI simulation here. Same program, uh, same program I've written in the advanced version PLC software, that is ISP software. Same thing. See here I'm using normally open of on switch and falling edge detection of low level sensor of overhead tank, and then X3 is high level sensor of overhead tank, and X1 is some sensor. Same logic. Okay. So now, so I've written the program, but how it is, you should analyze, I'm just explaining. Okay, first we have to go to the simulation here. So we have to switch on the start simulation. The program is downloaded to the simulator, and now we'll go to the offline simulation. This is also Delta PLC software, but little advanced version, so that we can have simulation of HMI screen at the same time. Okay, so this is this is only for understanding purpose. This is a sump, this is a overhead tank, and sump has got the sump sensor. Okay, and overhead tank has got low level sensor and high level sensor, and there is a pump here, motor pump is there, and there is a on switch is there. And to control the animation, here we have taken the sliding bar here. Okay, so it is nothing to do with the program. just to understand and make you understand how the simulation is used. Okay, so how the program is going to work, that is what I'm going to explain now. See, say for example, if you switch on the on switch one time, that means see here, if you switch on the switch, that means it should be okay, online mode. If you switch on the switch, see here, if you switch on once momentarily, uh, even though it is not getting on, because we are assuming that some sensor is uh, off. That means why? Because tank is completely empty. So sorry, sump is completely empty. So first I should make sure that some should have enough water. So I will increase the water level. So what happens? Sensor status is going to change. That means sensor is going to on first. First some sensor will be on, right? So I'll go to the sum sensor, that is x1, and then I'll force it to on because enough water is there. So in this condition, see here, if water is there in the sump, then only motor is going to on. Now enough water is there in the sump and some sensor is on. Now if you operate on switch, motor to be on, motor should be on. Okay, PLC is in stop mode, sorry. PLC should be in run mode. See here, it is in run mode. Now if you operate this start button on switch, see here, motor is on. Motor is on means the pump start pumping the water to the tank. So what happens? Now water level in the overhead tank slowly rises. Now water level is just above the low level sensor. So what happens? Low level sensor will be on. So I'm going to here, low level sensor, going to force it. Now low level sensor is on. But still pump is on. Motor is on because it should fill until it's get filled. Right? So slowly now water level is rising, 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 rising. If water level is full in the overhead tank, then what happens? High level sensor is going to on, right? Once high level sensor is on, see here, motor is off. Okay, so filling stops. Assume that water in the overhead tank, it starts consumed by the user. So what happens? Water levels now rising, sorry, decreasing. When water level is lower than the high level sensor, what happens? High level sensor goes off. But but motor should not be on again. Okay. So here our control is to not to maintain the high level always. So here when water in the overhead tank is really low, that means lower than the low level sensor. That means when water overhead tank is empty, then only motor should be on. Otherwise, that is a different type of control. Okay, this is the house like home application it is used. Okay, so now water level is reducing, 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 and water level is really lower than the low level sensor. Then low level sensor goes off. So this is the application of falling edge detection. Off. Then automatically motor is on. I hope you understood. So we are assuming constantly that some sensor is on. That means enough water in the sump. Okay. So I'll repeat once again. Uh, Now what happens? Pump is on. So pump is on means what? What happens? Overhead tank level rises slowly. If water level is higher than the low level sensor, what happens? Low level sensor will be on, but still it is pumping. Yes. So water level rises. When water level is really high and it's full, then X3 will be on, then motor is off, it stops pumping. Then now draining starts, that means water consumption starts. If water level is low, then the high level sensor, will be off, but still motor is not on, not required. Then when water level is really low, lower than the low level sensor, then low level sensor is off, again motor is on. Okay, but if some sensor is off, say for example water level is completely lower than the low level sensor, some low level sensor, then since we are using normally close, this sensor will be on, sorry, sensor will be off, sensor is off. Okay, sensor is off because there is no water in the sensor. If sensor is off, then what happens? If low level sensor, if some sensor is off, then filling stops, even though overhead tank is empty, because it cannot fill water because there is no enough water in the sump. So this is how I'm explaining this project, PLC logic. So I'll go back to the WPL. Okay, I'll close this because this is also Delta software. It's also Delta software, so it is not going to work. Okay, I hope you understood. So now I'm going to simulate this one. I'm going to switch on the simulator, then online. Should be in run mode. See, by default there is assumption some sensor is low. Okay, first you have to make sure that there is enough water in the sump, so you have to make sensor on. Okay, so there is enough water in the sump. In this condition, if you press on switch and if immediately off it, there is a push button. So motor is continuously on and it's pumping the water to the overhead tank. First low level sensor will be on. First low level sensor is on. Okay, and when tank is completely filled, high level sensor is on, so sensor is off. When draining starts, when water level start decreasing, then high level sensor will be off. And then when tank is completely empty, this sensor is going to off. At that time motor will be on again. So this will be repeated. This is what the automatically this controller starts monitoring the water level in the water tank. That means it won't make a water tank empty. So it's always is going to full. That is what the control is. Okay, so I have finished in only 2 lines, 2 networks of problem, and this is what the computation expects. Like say for example, 2 groups have done the programming correctly, but at that time we're going to check the number of lines. If number of lines are less, then those are the winners. Okay, so these are the criteria to select the winners. So if you have any questions, please put your comments in the comment section, and then I'm going to answer it. So thank you for watching this video. Thank you everyone. Please subscribe to my channel if you like this video. Thank you.